Hello, this little video is going to be about review on basics about functions. So it's a combination of different things: evaluation of a function, an average rate of change of a function that's not linear, otherwise it would just be a slope, right? Operations with functions, composition, inverse, one-to-one. So it's really just a very, very quick review of the basics. So first of all, if I have a function f of x is equal to x cubed plus 2x, for example, and I need to evaluate that at f of negative 2, well, it's just as simple as wherever I had an x, I now have a negative 2, so I replace all my x's with a negative 2, so that becomes negative 2, and that x used to be cubed, right? So negative 2 cubed plus 2 times x, and my new x is now negative 2. And then you just evaluate that. So negative 2 cubed will be a negative 8, and then 2 times negative 2 is negative 4, and so that will be negative 12, right? Negative 8 minus 4 will be negative 12. So that will be your answer for this one. Then I have f of 0, so that would mean that wherever I had an x, I now have a 0, so I'm going to replace all my x's with 0, so that will be 0 cubed plus 2 times 0, and 0 cubed is 0, 2 times 0 is 0, 0 plus 0 is 0, so that whole thing just goes to 0. Then I have f of x equals 0, so I threw this one in there purposely because too often we have that confusion, right, when the 0 is actually your independent variable, your input of the function, and you put it wherever you have x's, or when it is the output, the dependent variable. So that's what the function is equal to. So for this one, I'm going to go work on that side. I need a little bit more room. So here, f of x is still going to be x cubed plus 2x. But I want that to be equal to 0. So that f of x has to be equal to 0. And now I need to solve. So if you remember anything about solving equations like that, polynomials, you need to factor if possible. And so I can see that I have at least an x everywhere I could factor out. So factor out x. X cubed divided by x is x squared. And then 2x divided by x is 2. And when you have a product of two things and you get a 0, then you know that either x equals 0, therefore that will be your first solution, or x squared plus 2 equals 0, in which case you would subtract 2, will give you x squared is equal to negative 2, take a square root on both sides, and now we have a negative inside the square root, so that becomes your imaginary number, and so that will go to x equals plus or minus I square root of 2. Okay, so that will be what that will be equal to. Right here we're actually solving this for x when that's equal to 0. 0 is the output again, as opposed to here where 0 was the input. Okay, then here I have f of a squared. So that's when you have an input that's not just a number that you can actually plug in for x's, but it is another unknown. But it's still an input, right? So wherever I have an x in my function, I'm going to put in an a squared instead. So we're going to have a squared for this x, and then that's cubed, plus 2 times a squared. Well, when you have an exponent to an exponent, that's a good review of laws of exponents. A power to a power, we multiply them, so that will be 2 times 3 is 6, so that's a to the 6th, and then plus 2a squared. So that will be, and that's as far as you can go. You cannot combine those two terms because this is a 6th power, this is a 2nd power, so they're not the same. We can't combine them, so that will be it. All right, number 2. I'm going to switch colors so that they don't all just run together. Here we have a piecewise function. We're told that f of x could be 3 different pieces depending on what the x value is. So for all your x's that are less than 0, you're going to use 3x. For all the x's that are between 0 and 2, including 0 and 2, because it's all equal to, we're going to use x plus 1. And for all the x's greater than 2, we're going to use x minus 2 quantity squared. Okay? So f of -5. So your first job is to figure out where is -5. In which of those branches does that fit? Well, is -5 less than 0? The answer is yes. So this is the branch I would use. So I'm going to plug in -5 for this x. So I want 3 times -5. And that would be -15. Now, sometimes students feel confused about that, and now they want to go ahead and put a -5 here and here, but that's a no-no, right? Because -5 is less than 0, so it fits this branch, but -5 is not between 0 and 2, so it doesn't fit this one, and it's definitely not greater than 2, so it doesn't fit this one, right? So we're only going to place it in at one spot. F of 0, where does that go? Well, we have a 0 here and a 0 here, so which one of those two does it fit? Well, this one is not or equal to, so that doesn't fit 0. But this is or equal to 0 here, so we're going to fit it in here. So 0 plus 1. So 0 plus 1 is 1. The next one will be f of 1. So where does f of 1 fit? 1 is not less than 0, so it doesn't go here. 1 is between 0 and 2, so it's going to fit in that branch. 1 is not greater than 2, doesn't go here. So it's going to be this one. So it's going to be a 1 plus 1, which is 2. Those are functions, by the way, so we're only going to have one of those piece where the input will fit, right? You will never have an input that's going to fit more than one place, because otherwise that would not be a function anymore. Where does 5 fit as an input? So f of 5, 5 is not less than 0, so not here. 5 is not between 0 and 2, so not here. But 5 is definitely greater than 2, so 5 is going to go here. So we're going to have 5 minus 2, and then quantity squared. 5 minus 2 is 3, and 3 squared will be 9. So 9 will be your answer on this one. Okay, so that's for piecewise functions evaluation. The next one is we have to find the average rate of change. So an average rate of change is when you have a function that's not linear and you want to find kind of like almost if you would draw a line between 2 points, what would be the slope between those 2 points? So let me illustrate this with a picture. So if I have to graph this, this is a translation to the right by 3, so that will be a quadratic. That would look like that. Okay, it's not the perfect graph, but forgive me for that. I don't have a grid here, but it will be a quadratic that looks like this. And so if I wanted to find, see if I can do a little bit of a better job here. Let me move my paper a little bit. Can do a better job on that side too. So thankful for erasable pens. That looks more symmetric, doesn't it? Okay, we have a little bit better symmetry here. So if I need to find the average rate of change between 1 and 3, that means 1 is here, and 3. I really look for, if I would draw a line between those 2 points, what would the slope of that line be? And we know it's not going to be perfect. Between 1 and 3, it's not going to be an exact rate of change because this quadratic is not linear, obviously. So the slope is not going to be perfect, but it's going to be close enough. That's why it's called an average rate of change, right? Because it's not exact, but it is close enough. So the average rate of change, I would have to find what is my y value when x equals 1. So when x is 1, just like we evaluated above, plug in a 1 here. 1 minus 3 will be -2. And -2 squared is 4. So when g is 1, we're going to get 4. Then we need, so that will be up at 4 up here. And then we need when g is 3, what will be my y value, and when g is 3, the y value is obviously 0, so that will be 0. So now I have 2 points, and I can find my slope between those 2 points, even though this is not a linear graph, it's still going to be close enough, and that's what I want to use. So the slope would be y2 minus y1 over x2 minus x1. So the y of the second point minus the y of the first point. It is critical that you remember that the y value, the delta y, the change in y, is in the numerator, and the change in x's will be in the denominator, right? Remember that from your Algebra 1 and Algebra 2 days. So this here would actually give me my y is 0, and this y is 4, so 0 minus 4. And then the x's will be 3 and 1, so 3 minus 1. So that's a negative 4, and 3 minus 1 is 2, so that will be negative 2. So the average rate of change here will be negative 2. What is the average rate of change between 4 and 7? So let's change color again. So here we want between 4 and 7, so 4, and then 5, 6, 7. So that will be way up there somewhere, right? If I keep going on my graph, I would hit somewhere way up there, right, for the 7. So if I want the average rate of change between x equals 4 and x equals 7, that's an interval, meaning those are two x values. That's your x1 and that's your x2. So between x equals 4 and x equals 7. So x equals 4 will be here, x equals 7 will be up here. And so really what I'm looking for is I want to know if I would draw a second line between those 2 points, what will be the slope of that line, right? So you see how this already is not as good as this one was, right? It's already further away from the line, but it's still going to be an average rate of change. So we need the y values, right? I know when x equals 4, but what's my y? So we have to find g of 4 first. So if you replace your x with a 4 here, we're going to have 4 minus 3 is 1, and 1 squared is 1. So g of 4 is 1. And then we need g of 7, right, when x equals 7. So we're going to replace x by 7. 7 minus 3 is 4, and 4 squared is 16. So those are my two y's, those are my two x's. I'm going to use my slope formula. So y2, 16, minus y1, 1, over x2, 7, minus x1, 4. 16 minus 1 is 15, 7 minus 4 is 3, and 15 divided by 3 is 5, so the average rate of change will be a 5. Alright, now we are going to operations of functions. So I'm given two functions, f of x and g of x, and I want to add them. That just means take your f function and add the g function, and we keep x as an input. We are not going to change anything. So that's just really putting like terms together. So your f function is 3 minus x squared, and I want to add my g function, so x squared minus 4. So here is my g, here is my f, and I want to add those. So put your like terms together. So what's negative x squared plus x squared? Well, those will go to 0, right? So they cancel each other out. And then I have a 3 plus a negative 4, that will be negative 1. So that will be my answer. Now I want to subtract them. So I'm going to take my f function, 3 minus x squared, and I want to subtract g of x, which is x squared minus 4. Now this is critical that we realize that we're subtracting the whole g function, meaning this negative has to be distributed here, right? And that's going to be important. So I have 3 minus x squared, and then minus x squared, and then a negative becomes plus 4. Alright, put your like terms together once you distributed that negative. So I have a negative x squared and a negative x squared, that will be negative 2x squared, and then a 3 plus 4 will be 7. So that will be your answer right there. And then here I want to multiply f and g, and I want to put 3 as my input. So you could do that different ways. You could go ahead and plug in 3 first, find that value, plug in 3 here, find that value, and then multiply those two. Or you could first find f times g of x and then replace x by a 3. So it doesn't really matter which way you go. So just for the sake of reviewing multiplying binomials, I'm going to multiply first. So I want 3 minus x squared times x squared minus 4. And so when you're multiplying binomials, you're going to do, it's what sometimes it's called foiling, right? You do the firsts together, then the outers, then the inners, and then the last. So that will give me, the first together first will be 3x squared, and then the outers, 3 times negative 4 will be negative 12. Then the inners, negative x squared times x squared will be negative x. When you have the same bases that you multiply, you're actually going to add their exponent. So 2 plus 2 is 4, so x to the 4th. And then we're going to multiply the last. So negative x squared, don't forget the sign with it, times negative 4. That becomes a positive 4x squared. Now we're going to put our like terms together, and we're going to write it in standard form for a polynomial, meaning the highest degree first and then in decreasing order. So my highest degree, my highest exponent, sorry, will be the fourth power. So I have a negative x to the fourth first. Then I have a 3x squared and a 4x squared. Those together will give me 7x squared. And I do not have a linear term, meaning I don't have a term with just an x to the first power, but I do have a negative 12 here, so minus 12. So that will be our answer. That's for f times g of x, but now we need to evaluate that at 3. So actually I should not even have framed that, right, because that's not my final answer I'm looking forward, actually. Again, thankful for erasable pen. So really what I'm looking for here is I want to evaluate this when x is equal to 3, right? So when x equals 3, what is that going to give me? Well, that's going to be a negative 3 to the fourth power. And let's do that. Let's do that on the side here, on the little board. So we have a negative 3 to the fourth power, and then we have plus 7 times 3 squared minus 12. Okay, so 3 to the fourth power is going to be 81, so that's a negative 81. 3 squared is 9, and 9 times 7 is 63, and then minus 12. Alright, so we're going to have a negative 81 plus 63, so that will be 18, right? Minus, so that's negative 18, and then minus 12, right? Those two will be negative 18. Let's make sure again, so that will get 7 will give me to 70, another 11. So yes, negative 18 and then minus 12, and so that will be equal to negative 30, right? You agree with me? So I'm going to erase it here, and we're going to put that on our paper. So when we plug in a 3 for those x's, it's going to be negative 30. Okay? Then we go composition of function, right? That's the next thing we want to look at. So when we're composing function, this is not a multiplication, it's a composition, meaning we're going to have a function as an input, as opposed to just a value as an input. We're going to have a whole function as an input. Sometimes we write them like that with a little open circle, that means composition, or sometimes we just write them in function notation with the inside as a function as opposed to just a number. So we're going to work from the inside toward the left, toward the outside. So here we have a 0 that we're going to put into g first. So we want g of 0. So g of 0, when you plug in, when you replace x by 0, you have 4 minus 0 squared, which is just going to be 4. So g of 0 here is a 4, and now that 4 is going to be the input of f. So we're going to have f of 4, right? Because g of 0 is replaced by 4. And we want to plug in a 4 into the f function now. So 2 times 4 minus 3. 2 times 4 is 8, minus 3 is 5. So the answer here will be 5. All right? Now I want an f of 2. So the input here, the 2, is going to be entered into the f function. So I go here and I say, okay, I want f of 2. And so that will be 2 times 2, sorry, minus 3. 2 times 2 is 4, minus 3 is 1. So then that becomes a 1, which is going to be entered into f again. So I want f of 1. And when I substitute my 1 in for my x, I have 2 times 1 minus 3. And 2 times 1 is 2, minus 3 is negative 1. So the answer here will be negative 1. Then here, I do not have a value as an input. So I'm going to keep my x. X goes into g. Well, that's just going to be your g of x, right? So that whole function becomes the input into the f. So the whole g, which is your 4 minus x squared, that whole g becomes the x into f. So f has an x here, so that will be 2 times x and then minus 3. Right, that's my f function, 2 times x minus 3. But my x becomes my g function, and my g function is 4 minus x squared. So 4 minus x squared. And once that's set up, now we're just going to distribute. So 2 times 4 is 8. 2 times negative x squared is negative 2x squared. And then we still have that minus 3 in the back here. And now we put our like terms together. So negative 2x squared, and then 8 minus 3 is 5. And that will be your answer. Finally, we need to find the inverse. So we are given a function f, and we have to find f inverse. So to find an inverse, first of all, we want to replace f of x with y. So I'm going to replace that by y. Then we want to switch x and y. The input and the output are going to be switched. So that becomes my x. And that becomes my y. And now I'm solving for that new y. So to get to the new y, the first thing I need to cancel is the square root. And to cancel a square root, we have to square. So I have to square both sides here of the equal sign. So I'm going to have an x squared is equal to the square root squared just cancels. So it will be equal to 5 plus 8x. Oops, sorry, that should be a y. It's my new y, right? My new y. And I need to get y by itself, so I'm going to subtract 5 from both sides first. And then to get y completely by itself, I'm going to divide by 8. And so that becomes x squared minus 5 divided by 8. Is my y, but that's really going to be my inverse function. So f inverse is going to be equal to x squared minus 5 divided by 8. That's your f inverse function. So again, to find an inverse, we write the function name as a y. We switch the x and the y, switching input and output. And then we solve for the new y. So you do whatever inverse operation you have to do until the y is completely isolated. And then you rewrite it using the function name with a little -1 exponent, which indicates inverse. So that's the inverse function of f. Is this a one-to-one function? So one-to-one means that the function has an inverse that's also a function. And this will be the case here. This one is a one-to-one. That will not be. So we have to restrict the domain for that to be. So we're going to say with restriction of domain. It will be a one-to-one with restriction of the domain. All right. That's it for this one.